Good morning, good afternoon, good evening, ladies and gentlemen, and welcome to another video. I hope that you've had a wonderful day thus far and are ready for more mathematics. In this video, we'll be looking at binomial distribution. And yes, I can hear some groans out there because of that word distribution and my Pokemon Go examples. Well, it's not going away anytime soon, so we're going to do some more Pokemon Go examples with binomials this time. So, in this example, we have x plus 2, and then in the other bracket, we have x minus 3. Why is this called a binomial, actually? Well, that is because each bracket is made up of two terms. And as you guys saw in our distribution example, we know that this is one term because it happens before the plus, and then this is a second term that happens after the plus. So once again, first, second. So each bracket has two terms. So unlike in the distribution example, you now have multiple things to worry about. So for example, in this one here, you want to again catch them all. So you have an x here, and this x has to catch everything. So you've got an x on the other one, let's call that one Pikachu, and we got a Bulbasaur on the other one, that's the 3, the negative 3, don't forget the sign that's in the middle. So and then you have the 2 also has to multiply with the x, and it also has to multiply with the negative 3. Now, in the past, they've given this a nice fancy name, and they called it FOIL. Now, we'll go over why it's called FOIL after we've done this example, so let's get into the multiplication. Now, in the multiplication itself, remember, you've got to catch them all. So, x, pika, and by pika, I mean multiplies with the x times x gives you x squared. Have I caught the x? Yes. Then x has to multiply with the negative 3. Why is it negative 3? Because of that negative in the middle. So x times negative 3 will turn into a negative 3x. Why is it negative 3x? Because you're multiplying a number with a variable. And when you multiply a number with a variable, the number can't do anything but stand outside. Has x caught them all? Absolutely. X has caught them all. But 2 didn't, and 2's your brother, he gets left out. So 2 now has to multiply with the x as well. So 2 times x, they're both positive, so we're going to have a positive 2x. And then finally, 2 has to catch that negative, once again, negative 3, because of the negative in front of the 3. 2 times 3 is 6, with the negative on the outside. Now, once we have finished catching them all, have we finished catching them all? Yes, because 2 caught them all, x caught them all, 3 caught them all. So in our next line here, we have to do what we call gathering our like terms. Now, just like what we did in the common factoring videos, you had to look at what is the same. So when I look at my first term, you have x squared. Now, obviously, this squared means it is a different term. You're looking at this almost like you're looking at a banana. You then have negative 3x, positive 2x, and negative 6. Now, there's a reason why I put different squiggles beside each one, because x squared is definitely not the same as 3x. So you have here negative 3x, positive 3x. These are what we call like terms. They're like terms, as you recall in the last video, because they have the same exponent. They have the same letter, x, and they're both to the power of 1. They don't have a 2. So because there's nothing else that has x squared, we just bring the x squared down. Now, we have the negative 3x plus 2x. They're both like terms. So because they're both like terms, I'm going to do this on the side here. You have negative 3x plus 2x. This is the same thing like I'm saying, what is negative 3 apples plus 2 apples. They're both apples. Why? Because they both have an x, and both of the x's have the same exponent. So what's negative 3 plus 2? Well, negative 3 plus 2 is negative 1. So you have negative x. We don't put the 1 usually because we kind of understand it's there. So negative 1x minus 6. Nothing's happening with the 6 because there's no other thing that doesn't have a variable beside it. Have we done everything we could possibly do here? Yes. And that is how you do the binomial distribution. We'll look at one more example and then we'll call it a video. In this next example, I've modified the equation a bit by putting out a number on the outside. All right, so this number on the outside, what I want you to do is I want you to forget about this number until the very end. What I want you to do is I want you to do the distribution first. I want you to do your Pokemon Go first. I want you to catch them all first. Okay? Now, I did promise on the last page I'd tell you what FOIL is, but that was a little white lie. I'll tell you about that on the third page. So, in this example here, we're going to catch. So, once again, I am forgetting about the -3. I'm just going to put it there. And then we're going to continue on. You have x times x, x squared, plus 3x. We caught them all. Minus 2 times x. We caught that Pikachu. And then minus 2 times 3 is minus 6. Once again, we are then going to collect our like terms. So 1, we distribute. 2, collect our like terms. Okay, so once again, what are our like terms? Well, 3x, -2x, they're definitely like terms. So plus 1x, because 3 minus 2 is 1, and then minus 6. Once you've done that part, then you still have that -3 on the outside. Now at this point you remember it's there. And once again, yes, I can hear the cringes coming. You are going to use Pokemon Go. That -3 has to catch all of these things. So, -3 times 3x squared is -3x squared. -3 times x is -3x. And -3 times -6, well, that's 2 negatives. So 2 bad apples gives you a good apple. That's plus 18. Is there any other expansion for me to do here? Nope. So we are done. We'll go over what FOIL is in general in the next and last slide. So finally, FOIL itself is basically the general term that we're going to use that associates the stuff that you get after you've finished multiplying everything. So we're going to do that using letters because, yes, I can hear people saying, yay, letters. Yes, of course, I can hear the cheers. So once again, assume you're using these letters, you're going to Pokemon Go it. If you haven't been tired of that joke yet, get ready. So A times C is AC. I'm going to do this all with different colors. Plus A times D is, well, A D plus B times C. I'm going to do that with a different color. B C and plus B times D, which is B D. I'll use white for that. So, what are we noticing here? What we're noticing is we have, in our first term here, I'm going to use a black here. No, black does not work there. We'll use green. So, green, AC. Well, what is AC? Well, A and C are both our first terms. The first terms of each bracket. So, F. So I'm going to write a nice FOIL here so you guys can see where we're going here. So this is the first terms. Of course, the O, well, let's see what's happening here. AD. Well, A times D. Well, A times D, those are both of our outer terms of each bracket. So that is the outer terms. And then you have here BC, British Columbia. British Columbia, we have here and here. And BC, if you notice, are the inner terms of our brackets. And finally, we have BD, a bad day. So when you have a bad day, we realize we are at the last part of our day. And that is why L is our last terms. So every time you do a binomial distribution, you should end up with 4 separate terms before you collect like terms, which are the first terms, the outer terms, the inner terms, and finally the last terms. So that is binomial distribution. I have you all have a great day, the opposite of the bad day term. Take care.